Okay, ladies and gents, welcome back. We got 7.4 here. We're going to be dealing with inverses. Just to do the bell ringer quick, we're going to do the graph for f of x. Okay, if I put negative 2 in here, that will give me negative 4 plus 2, so this is negative 2. If I put 0 in, 0 plus 2. And then 2 I put in, I got 4 plus 2, which is 6. I'm going to plot those quick. Negative 2 down 2, get 0, 2. And 2 up 6, 2, 4, 6. As far as that line goes. Okay, there's our graph of that guy. I'm going to do h of x in red. So if I put negative 2 in here, half of negative 2 is negative 1. So it's negative 2. If I put 2 in here, then half of 2 is 1. 1 minus 1 is 0. And then if I put 6 in, half of 6 is 3. 3 minus 1 is 2. So when we plot these, we've got negative 2, 2, negative 2 again. 0, up 2 again. And we got 6, 2. Actually, I had 2, 0 in them. So 2, 0 is here. And 6, 2, 2, 4, 6, 2. So, there's my line. Okay? Basically, what you're looking at here, these are inverse functions. Okay? So, explain what you noticed about the graphs. They're reflecting about the line y equals x. Now, if I put that line on here, basically the line y equals x is this guy. Okay, so it mirrors on both sides. So where it is here, this distance here will be the same as that distance. So really, this is your introduction into inverse relationships. Okay. And let me shift down here for you. Okay, so let's fill in your chart here. It says the graph of an inverse function is the blank of the graph of the original relation. Okay. And the line of reflection is y equals x. The inverse function is the reflection of the graph of the original relation about y equals x. Find the inverse of a relation that is given by an equation in x and y. This is important here. Switch x and y, and then proceed to solve for your y. This will give you your inverse function. And you will see a couple of these in the next page. Okay. If you're going to test if two equations or functions are inverses or not, you can do compositions. If you do f of g of x, and that turns out to be x when it's all said and done, that checks out. You still have to switch the two and make sure it also works when you do g of f, which is x. We'll look at a couple examples of those. Don't panic about that yet, but we will get there. We will also talk about, here's a notation thing. F to the negative 1 is f the inverse of that. So if you see f or g to the negative 1, you know that that's the inverse of the original g of x, or f. So shifting down, solving for an actual inverse relation. We'll do 1 and 2 here, and I'll give you a little bit of a break, or you can hit pause whenever. Find an equation for the inverse relation. So this is my original. What I need to do is I need to switch x and y. So I'm going to put x here, I'm going to put y here. So switch the x and the y, and then proceed to solve for y. So to do that, I would have x plus 3 equals 3y, and then divide everything by 3. So my inverse relationship would be x divided by 3 plus 1. This is my inverse. Okay. I'm going to do the same thing for 2 here. Here is my original. I'm going to switch the x and y, so x equals negative 4/5 y plus 11. So I'm going to subtract 11 over, and x minus 11 equals negative 4 over 5 y. I can then multiply the 5 out. So this is 5x minus 55 equals negative 4y. And then I'm going to divide everything by negative 4. So 5x minus 55 all over 4 equals y. This is my inverse. Okay, ladies and gentlemen, let's take a look at number 3. Again, switch the x and y. We're now solving for y. This is x minus 7 equals negative 12y. I am then going to multiply by negative 1/12, or I can just think of this as division by negative 12. So I can think this is x minus 7 over negative 12 equals y. There's your inverse, ladies and gentlemen. Okay? And I think there's an R there. Moving right along. Let's take a look here. We got x equals 8y minus 13. Again, I'm going to add 13 over, get rid of addition and subtraction first. I am then going to get rid of this multiplication by 8. So I'm going to get y equals x plus 13 all over 8. There's my inverse. So that takes care of those 4. We are now going to move to the part where they say verify that f and g are inverse functions. We can use 3 different methods. We can use graphing. We can do it solving one of them. Or we can actually do what was at the top of the page and test their compositions, which would be f and g of x and g of f of x. So the first one is to actually solve for one of the inverses. All right, and I'm going to do that with, let's do it with this one. This one is a little more simple. So I got g of x, which is equal to 2x minus 2, which means y equals 2x minus 2. I'm going to switch my x and y, so this would be x equals 2y minus 2, which then gives me x plus 2 equals 2y, and then I'm going to divide everything by 2. So my inverse would be x over 2 plus 1. Now, this is f of x, so yes, they are inverses. Get this in my arm. That would be method number 1. Method number 2 is to actually test f of g of x equals x and g of f of x equals x. We'll do the first one in blue. So I'm going to go f of 2x minus 2. So that would be 1/2 2x minus 2 plus 1. Distribute my half in here, which would be x minus 1 plus 1. And yes, that equals x. Checked out. To do g of f of x, so I would do g of 1/2 x plus 1. I'm not going to have room here, so I'll write it down below. This would be 2 times 1/2 x plus 1 minus 2. So I'm going to distribute this 2 in. That's going to give me x plus 2 minus 2. That equals x. Checks out. So yes, they are inverses. So the next and last way to check it, the third method, is to use graphs. And I'll give you a second here. I'll punch up the graphing calculator. Let me shift this around a little bit. Then we'll look at this one again with a graphing calculator. Okay, ladies and gentlemen, welcome back. You can see I took the time to punch in our equations. F of x, okay, that's the one up here. I got g of x here, and here's my line of reflection. So when I hit graph on that, let's see what happens. I'll have to delete the blue and red lines for you. Okay. Here is my y equals 2x minus 2. Here is my line for the half x plus 1. You can see that they reflect about that other line. So, yes, these are inverses again. Okay? So, you can also see here that everything is basically flipped. 2 is the same, and moving right along, you can very easily see they reflect about the line y equals x. Best So to finish up here today, we're going to just test to verify that these are inverse functions. I'm going to do f of g of x method for half of them. Let me fix that quick. g of x. I'm going to test that for x, so this would be x minus 7. So I'm looking at x minus 7 plus 7. So f of g of x, yeah, that's going to equal x to 7 minus 7. So I'm going to check. And now check g of x, g of f of x. Okay, so if I do that one, I'm going to leave a big blank where the x is. I'm going to put this in the f of x, x plus 7. Yeah, that equals x. So, yeah, these are inverses. Yay. This one's a little more challenging. Okay, I'm actually going to do this old school. I'm going to go x to the 5th plus 2 over 7. I'm going to switch the x and the y. And I'm going to see if this gives me what I have here. So first order, I'm going to get rid of the 7. So I have 7x equals y to the 5th plus 2. I'm going to subtract the 2 over, so this is 7x minus 2 equals y to the 5th. And then take the 5th root. So y will equal 5th root of 7x minus 2. And then I check, does this match this? The answer is yes, it does. So again, yes, these are inverses. Okay, that would be the old school method. Great. Moving down here, let's finish up the final two. Obviously, I would like you to try this before you look at it. But again, I'm going to do the f of g of x method here. Make sure that equals x. So if I do f, notice I leave a blank where the x was here. I'm going to put this in here. This would be the 5th root of negative x over 2. The exponent here and this cancel out, leaves me with negative x over 2. So this here would be positive 2x over 2, which is just x. So far we're good. Now I have to check that g of f of x also equals x. So now I'm going to rewrite g of x, which is this big, lumpy problem here. I leave a blank where the x is. I'm going to put this in here. So that's negative 2x to the 5th. So when I go through this, this is the 5th root of 2x to the 5th over 2. 2 negatives make a positive. 2 divided by 2 is 1. So I have 1x to the 5th root of that is x. So yes, this works as well. They're definitely inverses. Okay. Oh, finish up here with the last guy. Go old school again. I'm going to use y equals 3x to the 3rd plus 1. I'm going to switch the x and the y. And I'm going to proceed to solve for y now. Again, get rid of addition, subtraction first. I am then going to get rid of division. So I have x minus 1 over 3 equals y cubed. And then I'm going to get rid of this exponent. I see that this is exponential. I'm going to raise this to the 1/3, which means I raise this guy to the 1/3. That gives me y to the 1, x minus 1 over 3 to the 1/3. And yeah, it's a happy meal. These match up. So, yes, again, and see if I can spell this in a very nice manner. So there's your whole section. Don't be afraid to go back and look at it. Again, fire questions at me where you feel you need a little bit of help, and we will be here to help you. You guys take care. Enjoy your evening. Pray for spring.